Hello class, today we are going to talk about indirect measurement. What indirect measurement is, this is a method that we can use to measure things without actually measuring them. So for example, maybe something's too tall. You don't have a tape measure long enough, or you can't get all the way up to the top of it, right? Like measuring how tall a tree is. Very difficult to do that directly, and so what we use is indirect measurement. There are a couple of different methods here that we are going to talk about. The first one, this is the shadow method. This was invented centuries ago by a guy named Thales, so at least it's attributed to him. He wanted to know how tall the pyramid was, and he couldn't actually measure from the top of the pyramid straight down. I mean, he could measure the lateral height, but he couldn't measure straight down. But he then realized that he could measure the pyramid's shadow, right? And he could measure his own shadow or something else. And what he did is he knows that at any given time, the angle made by the sun on the pyramid would be the same as the angle made by the sun on this little pole that he drove into the ground. And height is always a right angle, right there. And so this creates two similar triangles. We know they're similar because they have the same angles. This is angle-angle similarity, and so the triangles will be proportional. And so he can set up a proportion. He knows that his pole is 6 foot tall, and the shadow is 4 foot, and the shadow of the pyramid is 320 feet, and so he can set up a proportion for this. Right? Then use cross products here, and you have 6 times 320 equals 4x. Multiply that out, divide by 4, and we have that the Great Pyramid is 480 feet tall. All right? And this is the shadow method, and so he was able to use similar triangles and proportions to measure how tall the pyramid is, even though he couldn't measure it directly. All right? Another method we can use is called the mirror method. And the way this one works, you put a mirror on the ground and you stand over here, you look at the mirror and you position that mirror to where the reflection of the top of whatever it is you're looking at is in the middle of the mirror. And then you can measure from the mirror to your feet and from the middle of the mirror to being directly underneath whatever it is you're looking at. And again, since height is always perpendicular, you've got that angle the same. And since light reflects off of the mirror at the same angle it hits the mirror, you know these two angles are the same. And once again, you have angle-angle similarity. So your two triangles here will be similar, and you can set up a proportion. Now notice this. This right here. This is 5 foot 6 inches. So you got, and these are on feet. So you can't just set it up as 5/6 over 2. You need to either change this into completely being in feet, or you need to change everything to be in inches. With this one, I'll change it to feet because 5 foot 6 inches, that's easy enough. That's just 5.5 feet, right? So I'm going to do this as feet. So we have 5 foot 5 over 2 right here, and then my height over my distance there. So height over 8. Again, cross products there. So 2h equals 5.5 times 8. 2h is 54. H is 22 feet. Just so you can see this, we could do this all in inches. If we do this in inches, we have 66 inches. 2 foot is 24 inches. 8 foot is 96 inches. All right. Still going to do cross products there. And we get this. It's a little bit uglier because then at the end we have to change it back into feet. Right? So. Alright, but still just setting up a proportion. That's all it is. Alright, now then you also have this method. This is if you want to cross a river, you can't very well look at how tall something is, and rivers don't cast a shadow. So we have this. And this method, I don't know what it's called, but whatever, was devised supposedly by ancient armies. The military, they'd come up to a river and they're going to attack a city or whatever, and they need to get across the river. The river doesn't have a bridge because the defending armies burnt the bridge down to keep you away, and so they've got to build a bridge. But they can't just measure it. They don't because they can't get across the river. The river's too fast. You can't swim it. And so they would need to know how many trees to cut down to build a bridge so they could get across. And this is how they would measure it. All right, they would find some point on one side of the river, come directly across the river and mark that down, come some distance to the side, which they can measure that because they're on this side of the river, and then come over another distance, it's maybe 8 meters, and then back up until they have this in a straight line, and they can measure that. And again, you have a right angle here, you have vertical angles right here and right there, and so you have, again, angle-angle similarity. All right, so you set up your proportion. So 14 over 8 equals width over 20. Going to do cross products there, so you have 8w equals 14 times 20. 8w is 280, divide both sides by 8, and the river is 35 meters wide. Okay. Another method you can use for width is something like this. It's a little bit easier to set up. Tricky part here is making sure that this is 90 degrees, same as that. But again, notice you have, if these two are both right angles, then you've got parallel lines. And so again, corresponding angles are congruent, and so this angle is congruent to that angle, and so again you have angle-angle similarity. All right, and you can set up a proportion. So here the proportion is a little bit trickier, because the 80, that's the entire length of the side, right? The 32 is not the entire length of the side. So a proportion here, you can have x over 60, but the other one is going to be x plus 32, the entire length of side AC over 80. Well, it's still not a problem. We're just going to do cross products, right? So you have 80 times 80 times x, but then what do we have for the other side is 60 times x plus 32. So still not too bad. You're going to distribute that 60 in first. So you have 80x equals 60x plus 1920. Subtract the 60x so you get all your x's on the same side of the equal sign. And then divide by 20. And so here this river is 96 feet wide. All right. And so here are just 4 different ways of doing indirect measurement, different ways of measuring things that you can't actually measure directly because the river is too fast, you can't swim across it with a tape measure. All right. Or maybe you want to measure a highway. You can't just run a tape measure across the highway because then people are going to run over the tape measure and it gets all tangled in the wheels and they crash and people die and it's all your fault. Right? So instead we use indirect measurement. Right. Okay, so notice all of these we use angle-angle similarity to set up congruent similar triangles, and then it's just a proportion. One thing do be careful of, if you have feet and inches, don't get those mixed up, and make sure you change everything to feet or everything to inches. All right. And there it is. Indirect measurement. Hope you found that useful. I will see you in the next video.